Okay, section 2.6 is on rational functions and asymptotes. We are going to color code all the different types of asymptotes we can find for these. This is definitely one you're going to want to study, make flashcards for, because there's a lot of different asymptotes. So first, a rational function is where, you can see there, r of x equals n of x over d of x. This is just fancy way of saying the polynomial in the numerator, n of x, versus the polynomial in the denominator, d of x. So n of x and d of x are polynomials, and they're written in a fraction. So the first type of asymptote we're going to keep an eye out for is vertical asymptote. I'm going to make that green today. Vertical asymptote happens wherever d of x equals 0, and there's no matching factors. We'll talk about that in a second. But remember, for dividing, you can never divide by 0 if plugging in a certain x value forces you to try and divide by 0. You can't do that, so you get what's called a vertical asymptote. So first you make sure there's no matching factors. So it needs to be in factored form. This one is in factored form. You could put some imaginary parentheses around the top separately from the bottom if you'd like. X minus 5 over x plus 1, there's no matching parentheses, there's no matching factors. So the bottom is going to give you a vertical asymptote, and the way you get it is by setting it equal to 0. You could probably do that in your head, zero product property. X equals -1 is our vertical asymptote. Test is going to have a lot of answer blanks, or you can make the answer blanks for yourself. The vertical asymptote happens at x equals -1. Notice it says equation over here. Without the x equals, it is not a vertical asymptote, it's just a number. So make sure you remember x equals for your vertical asymptotes. Next example, you have to factor it first. So notice the top was factored. You could put imaginary parentheses around the top if you'd like. They finished factoring the bottom, and then they did have a matching factor. I'm going to make this pink. That'll be important for later. The x plus 3 over x plus 3 is matching. So it is not, you don't cancel it, and it is not a vertical asymptote. So once you've matched up anything on top and bottom, anything left in the denominator will give you a vertical asymptote. Zero product property is how you get it, and x equals 4 is the vertical asymptote for that rational function. Number 3, factor it. Once it's factored, check and see if you have any matching factors. Since it's x minus 1 over x plus 1, that doesn't actually match. So you end up with 2 factors in the denominator. Each one, zero product property, gives you 2 vertical asymptotes. So you might have more than 1 vertical asymptote. Okay, this is vertical asymptote. From the denominator, ignoring the ones that match. Well, obviously we can't just ignore the ones that match forever, so if they don't make vertical asymptotes, what do they make? Well, they make holes. So I made those pink on the previous screen. I'm now going to keep them pink. Holes is going to be pink. It's when there are matching factors, the factor in the denominator that matches in the numerator, you will get a hole. A hole is a point that needs to be written as a point. So make sure you write your answer as a point for hole. Let's write that over here, x comma y. So same thing, you have your rational function. You factor, maybe the top needs to be factored, maybe the bottom needs to be factored, maybe both need to be factored. You find any matching factors on top and bottom. You set that factor equal to 0. And what you get is the x coordinate of the hole. So zero product property with the x plus 4 gives me -4 for the x value. So that's where this number comes from. To find the y value, you go ahead and simplify your expression. X plus 4 over x plus 4 cancels out, but remember when it cancels out, you still have a 1 left, which is where the next equation comes from. Then you plug your answer in. We got -4 for x, so you plug that in, which is what happens as you move to the right. You do the math, and then this answer gives you the y value, and the answer to your hole is always a point, and in this case it's -4 comma -1/5. But we're learning things, so let's keep adding to it. The 1 left over in the denominator gives you a vertical asymptote. Zero product property with that gives me a vertical asymptote at x equals 1. So now we would have 2 of our answer blanks for this example. So far, factor in the denominator that does not match gives you a vertical asymptote. Factor in the numerator and denominator that does match gives you a whole. Zero product property gives you the x value of that whole, and plugging it in gives you the y value, remembering that the answer to whole is a point. Really quick for those of you that are interested, the reason it gives you a whole, by the way, is because, for example, if we plug -4 into this, it'd be -4 plus 4 over -4 plus 4, -4 minus 1, right? -4 plus 4 is 0. The bottom's going to become 0, and you get 0 over 0. Things freak out when you have 0 over 0. What's 5 over 5? Well, 5 over 5 is 1. Well, what's 0 over 5? Well, 0 over 5 is 0. So we have this rule that a number over itself is always 1, but then we have this other rule that 0 over anything is 0, and these don't, jive together, right? It doesn't make sense. So math freaks out, and you get a whole instead. It's not possible. Also, when we start graphing these, it's important to note that you would graph this as a hollow point, right? An open circle. Okay, moving on to horizontal asymptotes. I'm going to make horizontal asymptotes blue today. HA for horizontal asymptote. Horizontal asymptote is based on the degree comparison between the n of x and the d of x. Remember, n of x is the numerator, d of x is the denominator. So we have 3 possibilities. The degree of the numerator could be less than the degree of the denominator. If that's the case, we already know the answer is y equals 0. Horizontal asymptotes are y equals. So if you look at our first example, remember we're looking for the degrees. So the highest exponent in the top is this imaginary 1 in the exponent, and the highest exponent at the bottom is 2. So if you compare those, the degree of the top is 1, the degree of the bottom is 2. So let me write this easier. The top is smaller. That's how you can think of it. If the top is smaller, you know that the horizontal asymptote is y equals 0. You don't have to do any work. You'll learn why when you get to calculus. It's about limits. If I was plugging, basically limits means you're plugging infinity in. If I have infinity times 3 plus 2 divided by infinity squared plus 1, the bottom gets bigger faster, and so you end up with the horizontal asymptote at y equals 0. Okay, so then the other option, the degree of the numerator could equal the degree of the denominator. In that case, you have to do a little bit of math to find the horizontal asymptote. It's y equals the leading coefficient over the leading coefficient. So in this example, it's something x squared over something x squared. So the degrees match. So you grab, assuming they're in standard form like this one, you grab the leading coefficients, 3 over 5, and the horizontal asymptote is y equals 3 over 5. And that's because if you think about limits, the top and the bottom are going at the same rate, and the rate is 3 over 5. Another example, we have factored form and with fractions. So the first thing that we did was we multiplied that 4 over to the x to get rid of the fraction. We multiplied this factor by 4, and that's where that comes from. Very rare that you will have fractions in your factors. And then we need to multiply it out to check the horizontal asymptote, but we don't need to multiply everything out. We just multiply the biggest terms together on the top and the biggest terms together, the ones with the x's, the biggest x exponents on the bottom, And this would be 4x squared dot 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 over x squared dot dot dot. And since the exponents, the degrees, match, we grab the leading coefficients, which is 4 over an imaginary 1. And the horizontal asymptote would be y equals 4 over 1, which is just y equals 4. The last option, we did top smaller, top and bottom equal. Last option, top bigger. The numerator on the top is bigger. In that case, the horizontal asymptote doesn't exist because this graph is going to go on forever. If I just make one up, I don't know, x cubed plus 2x over x plus 3. The degree on top is bigger than the degree on the bottom. So when I plug in, remember talking about limits, infinity on the top and infinity on the bottom, infinity cubed is going to be huge. So there's no horizontal asymptote. This graph is never going to stop. It's going to get big really, really quickly. So the way we would answer that, by the way, I'm out of space. I'm going to put it over here. Horizontal asymptote, DNE for does not exist. If the top is bigger, the horizontal asymptote does not exist. So I do want to kind of shorten this up in the margins. This is just my own shorthand, right? The correct math is written in the typed into the notes. This is how I remember it. Sorry. Degree. It's all based on degree. I'm just going to use n for numerator and d for denominator. So numerator smaller than denominator, y horizontal asymptote, y equals 0. Numerator equals denominator, again, degree of horizontal asymptote, y equals LC over LC for leading coefficient. Numerator bigger than denominator, degree of the numerator bigger than degree of the denominator, horizontal asymptote does not exist. So this is what I'm talking about, flashcards. Make some flashcards for asymptotes, especially horizontal asymptotes. Okay, the final type of asymptote we might have is a slant asymptote, or SA for slant asymptote. You find out the slant asymptotes by comparing the degrees of the numerator and denominator, and it has to meet all of these criterias. The degree of the numerator has to be exactly 1 higher than the denominator. If there's a hole and f of x is reduced to the lowest term, then the degree still must be 1 degree higher. So basically it needs to stay 1 degree higher. And then when you divide, you have to get a remainder. If you don't get a remainder, it does not exist. So here's an example. We have the degree on top is squared and the degree on the bottom is 1, so it is 1 higher. We do synthetic division to do the division, and you see that we get a remainder of 3. The stuff that's left is your slant asymptote. Remember, this was squared, so now this is 2x, and this is the constant minus 1. You write it as an equation, y equals, the slant asymptote for this one is 2x minus 1. Y equals 2x minus 1. Because we are still comparing the degree of the numerator and the denominator, here's what we need to know. Sorry, shapes. It's based on the degree again. The numerator needs to equal the denominator plus 1. Again, degree of the numerator has to equal degree of the denominator plus 1, which means if a horizontal asymptote exists, slant asymptote does not exist. You can't have both because the degree rule doesn't match up correctly. So if you have a horizontal, you can automatically put DNE for slant. If you find your slant asymptote first and you find one, you can put DNE for horizontal. You can't have both. Okay, so let's put it all together and do an example like you can expect to see. So first of all, whether the answer blanks are there or whether you have to write them yourself, this will always be what we are looking for. It doesn't matter what order you do them in, but make sure you put the answers in the correct answer blanks. So this one is not factored. So practice your factoring. Factor the top, the bottom is factored. Pause the video and take a second to factor that if you need to. There it is, factored. Now see if there's any of these answer blanks you can do right away. Some of the asymptote answer blanks are easier than others, I understand that. See if there's any of these you can answer on your own. Pause your video. So if I look for matching factors, I don't see any. So since there's no matching factors, there's no holes, right? I don't have anything to highlight pink. So this whole answer is does not exist. That leaves x plus 3 in the denominator. If I do zero product property with x plus 3, I get x equals negative 3 for the vertical asymptote. Don't forget the x equals. I like to look at the original equation for comparing my degrees, right? In the original equation, the top is squared and the bottom is 1. So the numerator is bigger than the denominator. If you go back and look, and make your flashcards, that means for horizontal asymptote, it does not exist. If the top is bigger, you can't have a horizontal asymptote. The graph's going to go on forever. It doesn't stop. That leaves slant asymptote. So for slant asymptote, again, I'm going to use the original equation on the side, set up my synthetic division. 1x squared minus 3x minus 4 are my coefficients. Negative 3 because it's opposite when you do synthetic division. Drop the 1, multiply, add, multiply, add, oops, negative 6, multiply, add. This is my remainder, but what matters is it does not equal 0, so I do have a slant asymptote, and it's y equals 1x minus 6. So my slant asymptote is y equals x minus 6. That was all work for my yellow slant asymptote. Okay, we are going to end up needing to graph these, so we might want to work on finding the zeros next, or the x-intercepts. So for zeros or x-intercepts, the equation equals 0. I'm going to use factored form in this case. Well, if it's going to equal 0, you could think of it as cross-multiplying. Multiply both sides by x plus 3, and it's still 0. For zeros, only the top matters. So the top is going to give me my zeros, or my x-intercept. Zero product property is going to give me x equals 4, and x equals negative 1. So my x-intercepts are 4, 0, negative 1, 0. My y-intercept, remember you always make x equals 0. So in my equation, this one's actually easier to use the original equation. 0 squared minus 3 times 0 minus 4 over 0 plus 3. Everything touching an x goes away, and you get negative 4 over 3. So my y-intercept is 0, comma, negative 4/3. And now let's see if we can get a sketch. I might have to add some half tick marks because I'm running out of space, but you do need tick marks on yours. So if you're on blank paper, make sure you add some tick marks. So I know I have, let's see, I'm going to go ahead and cut these all in half. So tick, tick. It is just a sketch, but we want the numbers we found to be accurate. Okay, so we have a vertical asymptote at x equals negative 3. So straight, I'm trying to make it the same color too. Vertical asymptotes up and down and dotted because it's an asymptote. Straight through x equals negative 3. We don't have a horizontal, we don't have a hole, but we have a slant asymptote. Slant asymptote has a y-intercept of negative 6 and a slope of 1. So up 1 over 1, up 1 over 1. You get the idea. Dotted line. Hopefully you guys can see my yellow line okay. I wanted it to match. I should make my green line a little longer because we want them to finish crossing. Now we should plot the points we know so that we know, let's talk about this. So it's a function. So don't draw this, right? But maybe the graph is here and here. Or maybe the graph is there and here. Or maybe the graph is here and here. But here's what you can't have. It can't be here and here, because that would not pass the vertical line test. So we want to figure out which sections of this, it's kind of cut into fours, right? Which of these four sections has my graph? So hopefully our points will help us figure that out. So 4, 0, 1, 2, 3, 4, 0, that's a point. So it has to be in that quadrant. -1, 0 happens to be in the same quadrant, so not so helpful, but that's enough to sketch it in. It hugs the asymptotes and keeps going. So that's one of my quadrants. Then 0, -4/3. That happened to land, that's like this point right here, lands in the same quadrant. So I still need to check something on the left of the green. Because remember, here are my options. We know the blue one. It could also be here, or it could also be here. So we have to check something on the left of the green. Well, the green's at -3, so let's check -4. Into your equation. I don't know which one's easier. Let's do factored, I guess. -4 minus 4, -4 plus 1, -4 plus 3. So this is -8 times -3 over -1, which is positive 24 over -1, which is -24. And I don't care so much that I'm not going to graph this all the way down to -24, but I know that's below the yellow line, so it must be here for my other curve. So it's just a sketch, but where it's located is correct. So just to be clear, let's make this purple. My curves are here and here, and I drew the asymptotes to get full credit. This is example number 1. Okay, here's example number 2. Set up all your answer blanks. See which ones you can find out. Actually, it needs to be factored first, so you factor that while I'm writing my answer blanks. Difference of squares over a trinomial factoring. Practice your factoring. See which ones you can find right away. Some of them are easier than others. First thing I notice is that I have an x plus 1 over an x plus 1. That's going to give me a whole. Zero product property is going to give me -1 for the x value, but remember it's a whole, so we have to find a whole is a point, so we have to finish it. So if I cross those out now, my equation is x minus 1 over x minus 3. I know x equals -1 from zero product property of the crossed out factors, so plug it in, -1 minus 1 over -1 minus 3. -2 over -4, simplify that, 1/2, -1 comma 1/2 is my whole. We have a leftover factor in the denominator. That's going to give me a vertical asymptote. Oops. Zero product property gives me x equals 3 for my vertical asymptote. If you go back and look at the original one, we have squared over squared. Those are the same. Do you remember, or go back and look, what does that mean for horizontal asymptote? Well, it means you grab the leading coefficients, which is 1 over 1. So y equals 1 is my horizontal asymptote. And since I have a horizontal, I can't have a slant. Don't just leave it blank, though. Does not exist as the answer for my slant. Okay, let's work on finding some zeros. Also, x-intercepts. So we can use the reduced form because we already know the x plus 1's cross out and give me a whole. So y equals 0 minus 1 over 0 minus 3. Oops, I'm finding the y-intercept. We'll come back to that. 0 equals x minus 1 over x minus 3. Remember, those times each other, you just get 0 equals x minus 1. You only get zeros from the top. You don't have to do this work. You can just tell me what the answer is. So I have an x-intercept at 1, 0. Now we'll go back and do y-intercept. Y equals 0 minus 1 over 0 minus 3, which is 1/3. Y-intercept, 0, 1/3. I'm actually going to erase that because it's a perfect spot for me to do my graph. Make sure you have it written down. Pause it if you don't. Set up a good graph and start plotting what we know. I'm probably going to cut them in half again. Okay, here's what we know. We know we have a vertical asymptote at x equals 3, dotted line straight through your x equals 3. We know we have a horizontal asymptote this time at y equals 1, that's sideways through y equals 1. We do not have a slant because you can't have both, and we do have a hole. So I'm going to graph this in orange. Our hole, -1, 1/2, needs to be clearly a hollow, -1, 1/2, a hollow circle. My Apple Pencil is not cooperating. There you go. A clearly hollow circle. But the nice thing about that is now I know where my graph goes. You don't just have a hole floating in the middle of space. The hole is inside your curve. So that means the curve must be down here, hugging the asymptotes. So we have half of it. Then if you look at our other points, 1, 0, that lands on my orange line. 0, 1/3 lands on my orange line also. So those 2 points weren't very helpful, but they're probably answer blanks. So we need to find something on the other side, because remember, again, it could be up here or it could be down here. So if our asymptote is at 3, we should plug in 4 into our simplified equation. 4 minus 1 over 4 minus 3, 3 over 1, +3. So at 4, it goes through +3, which means I know it's up here for my other piece, hugging the asymptotes. Okay, number 3, see what you can do. This is our third example. Try some stuff on your own. Try factoring it on your own. Try finding some of what you think the easier asymptotes are on your own. Okay, so as I was trying to factor the denominator, I realized it's not factorable. So we'll just leave that as 2x squared minus 5x plus 4. So since it doesn't factor, I don't have any matching factors in the denominator. And if you try to do quadratic formula with that, you will notice that it has no x-intercepts. So it has no vertical asymptotes because the bottom can't equal 0. It has no holes because none of the factors match. If we look at the original and compare the exponents, they're the same. So grab the leading coefficients. The horizontal asymptote is y equals 1/2. Since there's a horizontal, the slant asymptote does not exist. So the asymptotes aren't too helpful in this case. You're going to want to make a table to graph this one. First, we can do zeros. Again, top doesn't matter for zeros, so it's just the bottom. That gives me x equals 3 and -3. So x-intercepts 3, 0. -3, 0. Y-intercept. Everything else becomes 0. Well, let's use the non-factored form. All the x's become 0, which again, I don't expect you to show this. You're supposed to catch on and just kind of cross out all the x's and you get the -9/4. So y-intercept 0, comma, negative 9 over 4. And then pause it if you need to copy down my work. Make a table. Nope. Set up a graph, and then we'll see if we need to make a table. Close enough. So we have a y-intercept, horizontal asymptote, a y equals a half. So that's down here because I cut mine in half. So y equals a half. We have a x-intercept at 3, 0, negative 3, 0, and a y-intercept at negative 9/4, which is a little more than negative 2. So my suggestion, fill in some of these numbers that we're missing. So we have x, we have our equation, x squared minus 9 is probably going to be the easiest one to use. We have 3, negative 3, we probably want negative 2, negative 1, we have 0, 1, 2, maybe even 3 or 4, sorry, 4 because we have 3. Carefully plug in those numbers and see what you get. I'm going to pause mine and do the math. Okay, I showed a tiny bit of the work, but some of it I did in my head. I plugged in the numbers, I plotted the points, and you can see that it's kind of dipping down, coming back up, and hugging the horizontal asymptotes. Okay, we will practice this more in class, and I hope you're doing good. Hold on. Too soon. We have one more problem. So write a rational function with all this stuff. Okay, so I am going to color code it the way I have been. So vertical asymptotes, whole, horizontal asymptote, and it needs to be a function, so f of x or something like that. Here's what we know. It has vertical asymptotes at x equals 0. That means on the bottom, there needs to be a single x. Excuse me, I have the hiccups. To get a vertical asymptote at x equals 0. And it has one at 2/3. So here's the thing. We're not going to put fractions in our fraction. So to fix this, we're going to multiply both sides by 3. That'll give me 3x equals, those cross out, 2, and then minus the 2. So the factor that gives you an answer of 2/3 must be 3x minus 2. That takes care of the first two things. It has a whole at x equals negative 4, so that means it needs to match top and bottom at x minus plus, 4. It's negative 4 in the answer, so it's plus 4 in our equation. Let's match these up. Those were green. This matches top and bottom pink. And we need a horizontal asymptote at y equals 5. So first of all, in order to have a horizontal asymptote, the degrees need to match. And if I multiplied these out right now, x times 3x times x, I'd have 3x cubed on the bottom, but I only have a single x on the top. And what do I need the top to be? Well, first of all, I need it to be x cubed. They have to match in order to have a horizontal asymptote. And then I need them to reduce to be 5. So what over 3 is going to reduce to be 5? It needs to be 15. So I need 2 more x's because I already have 1. And I need it to be 15. So 15 x squared. But here's the problem. If I just leave it like that, this x squared over this x is going to make a whole, because those are factors where you get x equals 0 for the root. It doesn't say I have a whole at x equals 0, so I need it to not match. So I'm going to put it in parentheses. Right now it matches the bottom. I can literally put anything I want there, but I'm just going to put plus 1. Now it does not match the bottom, and it will give me the horizontal asymptote that I need, and it won't add any unnecessary or not given wholes. This is our final solution. Okay, now I'll see you in class, and I hope you're doing well.